I just realized something. I read about fair use laws on the internet, and basically, it seems like you can't share full texts of textbooks or any other kinds of books because it seems like that's not very legal. So basically, what I'm gonna do, it's allowed to share snippets. It's allowed to share parts of the code or stuff like that. So basically, I'm gonna more or less narrate what's going on, and we'll switch to code samples or snippets or any possible important things later on. So let's talk about evaluating our expressions. Not cat, I want to use Vim. Oh fuck. Vim error handling.c. Delete. Okay. So what should happen now is that we need to adapt the evaluation function, which is where is the evaluation function? This one. This is the evaluation function. We need to adapt it to deal with pointers of lvals and our new definition of what constitutes an expression. So what will happen? We will take as input a pointer on the lval object, and we'll return the same thing. So we need to make this transformer method now. We don't have any more these types. So what will happen? As expressions are arrays, and I think somewhere we have the constructor function for this, right? No, basically it's here somewhere. But the point is, as expressions are arrays, so we'll check any possible child as expression for errors. In this case, we'll return an error. Otherwise, we'll either return the expression or return possible child expressions. Okay. Okay. So, how will we do this? So first things first. Let's change the return type. And is it here? No, it's not here. Is it here? Maybe let's create a completely new method, and later we can edit it or remove it. So pointer to lval. And let's name it lval eval as expression as it writes in the book. So I'm following the Build Your Own book by Daniel Holden. It's a great book. Not only it shows you and it teaches you how to build a simple Lisp programming language, it also teaches you a lot of other concepts such as substrate search trees, natural grammars, of course, the C programming language. So it's a really great book, and it does this in less than 200 200 pages. So what will happen here? We are taking a pointer to an lval as an input, and we want to evaluate it. We want to evaluate it so we know what to do for each element that constitutes the S expression. So for let's iterate through it. So yeah, let's iterate to the we count, increase by 1. Okay. So okay, each S expression will have a element, right? What's the cell doing? Where is the constructor for this guy? Where is the constructor for this guy? lval? What is the cell doing? Let me just check something. How to search in Vim. I'm gonna search for cell. I want to see what it references in the code. So is it this guy? Is it this guy? Cell. How many do you have? How do I search other ones? We will search forward. So what is this the only place in which there is a cell? What? Cell. Ah, there are more. How can I? Is it tab? No, it's not tab. How do I? Cell. So we have it here. Where else do I? How? How to move to next search? How to move to next search element? Ah, it's okay. Okay, I get it now. Cell. There's another one. Actually, this is the one I wrote, and this one. Okay, so we don't have cells anywhere. This is the only place where we reference a cell. Basically, when we construct a new S expression in which we allocate the size of the lval structure. Okay, so I need to see what to do. So what will do this code? What will it do? What will it do? It will call lval eval expression again. No, it will call a new method, lval eval, on this place. Okay. So this will be a new method, right? Because we don't have. Okay, we'll need to also create the lval eval method, but let's continue. So how can we check if we have errors here? Can we check if we have errors? Again, but let's iterate if the cell. So what is the fucking cell on the ith element location, ith index as a type that is of type lval error. Again, what will we do? What will we do? There's okay, we'll return another method which we will also create. Okay. Okay, what's the next thing to do here? No, undo. Okay, what's the next thing to do here? If we don't have any, count is equal to 0, right? We'll just return v. If there's only one element, oops. What will we return then if we only have one element? What will we return here? Return. This method is something that I have no idea how it works yet. We will create it later. Okay, so next thing in the book says the comment. So I'm not coming to the, let me just show you what I have it here. So I'm usually just leaving my screen like this so I can read the comment and basically try to do it on my own. If I get stuck, I can just navigate further. So let's do, oops. So why would she do this? So I'm popping the first element, and then I most probably will check it against something. Against what? If it's not a symbol. Okay. What will happen? New methods, which I haven't yet created. Okay. Okay. And I'm gonna return something. I'm gonna create an error. To be honest, I have no idea why this is done like this. And then the comment says, call built-in with operator. The result is equal to built-in. Oh, again, a method that I have no idea what this is. Return result. Okay. So the next thing to do is to okay. Next thing is we will create this lval eval method. Okay, let's take a look. So in this case, we are iterating through all of our s expressions, and for every cell we have, for every S expression. We're gonna call lval. And what will this method do? Let's try to see. Okay. So if this is an S expression, we are creating this constructor. Otherwise, we are just returning V. Okay. Okay. So, what do we have here now? We are using two methods here that we called, but we haven't defined. Lval pop, and I think there's also lval take. Yes. I assume that lval pop will extract a single element from an S expression at a certain index, and will most probably shift other elements backwards. Now the lval take. Okay, so lval pop will get us the new element, but it won't delete input list. And the lval take is similar to lval pop, but it deletes the list it has extracted the element from. This is like taking an element from the list and deleting the rest. It's a slight variation, but okay. Okay. So let's create these two methods. Where am I? I'm here. So what do we have? We have lval pop. So let's think about it. I have the list of cells, right? I want to take one element out of it. So an S expression and the index at which it's located in. Okay. So how do I do this? How do I do this? How do I do this? Where do we call it? It's here, and we call it here somewhere. Where? Here. So we are popping the first element from the list. Okay. 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 I have no idea what this does. I have no wow. 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 Like I'm lost. I'm completely lost. Okay, we are decrementing this. This I know what it means. I need to see what happens here. Okay. This is the lval pop. look at the code snippet above. Explain me line by line what the code does and follow it with an example. Okay, let's see. This function removes and returns an element from an array of lval pointers at specific index I. Okay, lval pointers. We are going at the memory address now. These are the parameters. So a pointer to a structure of type lval. The structure presumably contains an array of lval pointers called cell and an integer count representing the number of elements in cell. Okay. Okay. Okay, we assign the element at index I of v cell into a variable x, this element that will be removed from the array and returned by the function. Okay. Now this line shifts the elements in the array to fill the gap left by the removed element. Okay. This is a function that copies a block of memory from one location to another, even if the source and destination overlap. Okay, so quite useful. Memory management method. Memory move, I assume. I assume this is the meaning behind this. Okay. So it copies a block of memory from one location to another. Let me think about it. This is the memory location that copies a block of memory from one location to another. Okay, this is the destination. Okay. So let me just switch back. Let me just switch back. So if this is a list of the elements, right? We have element 1, 2, 3, 4, 5. I don't know. I'm guessing it. And we want to pop up this guy. So at 3, at the memory address of 3, this is the destination. And the source starts from 4, because this is the next element. We also provide the address of this element. And this is the number of bytes to move, which is the size of the remaining elements after index I. So it's the size of lval. This is the size of how many bytes to move times v count minus I minus 1. V count minus I minus. So I should have 2 elements, right? I should have 2 elements. So if this is 2, It's 5 elements, minus 2, minus 1. 5 minus 2 is 3, minus 1 is 2. So we are starting from the... We are copying 2 elements. And that's the amount of bytes to move. Okay. Okay. This looked scary at first, but I think I understand it now. I understand it really good, actually. Okay. Okay. Let me just do something else. So this line shifts the elements in the array to fill the gap left by the removed element. Okay. Just a second. Okay, just grabbing my water here. Okay, we shift these many elements from the to this location. From this location, 2 elements. Basically, we'll remove the 3 in this example. Where's my... Let me just remove this and create something better. Basically, we'll remove the 3 and we'll pick these 2 elements, move them here. Okay. We also decrement the count of elements. Now what this does is we are resizing the array. Yeah, because we have an extra place now and we want to resize it. Okay, we also have an example. So what does this do? Okay, I get it. Okay, let's implement the lval take method. So this is the pop, and the take also takes a pointer. So what will we do? We will, oops. Oh, nice. We are using the pop method, and we'll delete everything else and returning the x. Okay. believe we are almost done. The only thing left is to define the evaluation function, built-in operator, built-in OP. So we'll do this. Just a second. Okay, so what is the built-in OP method and what will it do? What will it do? Built-in OP, pointer to A, character OP. So this will be the method. So what we should do here is this should be exactly the same, more or less, or similar to the eval operator method, which we have here. The only difference being is that it's modified to take a pointer to the lval struct. Okay, so it should check that all the argument inputs are numbers. Okay, if they are, then we'll pop the first argument to start. If there are no more sub-expressions, then the operator is... Okay, so we also evaluate single operations, such as unary negation. And if there are more arguments, it constantly pops the next one from the list and performs arithmetic depending on which operator we're meant to be using. If a 0 is encountered on division, it deletes the temporary x epsilon and the argument list A. And returns the error. Okay. If there have been no errors, the input arguments are deleted and the new expression returned. Okay. So where are you? Here. First things first. Let's ensure that all arguments are numbers. 4 in t is equal to this is less than what are we taking? A count, increasing the I by 1. If at any point the element at index I has a type that is different than the number type, can I just do return error, right? Cannot operate on non-number. And what else we need to do there? We need to delete. Okay. Okay. Okay, we're done with this one. So next we need to pop the first element. We'll name it them x pop a 0. So this is the first element. So in the book it says if no arguments and sub, then perform unary negation. I have no idea how to do this, so I'll just copy this from the book. So I'm getting the operator. So if the operator has a, okay, this and the count is 0. What are we gonna do? What have you done here? If the operator is a minus, a negation, And if the count of elements is 0, and it's 0 because we popped it from here and it was 1, the count was, in this possible scenario, it was 1. So once it popped, it's 0. Next, we are negating this number. Okay. Okay, now let's do something else. As long as the count is greater than 0. Pop the next element. Okay. Okay. So now I have the X element and the Y element. What should I do inside this method? What should happen inside this method? What should happen inside this method? If I think we can just copy. I think we can just steal our code from here, right? Where is the here? Here. How many can I yank? 5. No. 5. Yank. Paste. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Yank. Okay. Yankee. Where the hell are you? Here. And here, if I paste it, nice. How can I indent all of these? Actually, I'm just gonna compare if this is alright. Insert. Okay. So instead of returning stuff here, what we'll do? This guy will be equal to this guy. Okay, I also need to go over this code as well. Okay. I need this here. Let's continue. There's no way this works. What? Can I just do 3 delete? Oops. Vim. How to delete words? Delete words. So if I do, oops. So if I do 3 delete words, 2 delete words, 4 delete words. Okay. What have I done? This one's not returning this. Okay. Next thing. Okay, what else? X number divided equals epsilon number. Okay, I also have these two, but I think I should just comment them out for now, right? Let's do this. Shit. How do I? It's like this. It's like this. Is this now? No, I don't think so. Okay, let's do it like this. I must be fucking kidding me. I need to escape this guy. It's like this. No, it's the other one. I'm not escaping this guy. I'm escaping this. Right? No. Okay. How to escape in C. What? So the comments are not written like this. They are written like. Okay. 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 I get it. I get it now. My bad. Mea culpa. So this and this and this. And let's close it up. Okay. So what are we doing now? We are deleting epsilon. Wait. There's another extra here because just a second. Because this should be uncommented, but okay. Okay. Now let's only change main. Okay. First of all, let's go line by line. Let's remove everything that is not needed anymore. Let's clean up code. Let's understand everything better again. Okay, I don't need this one. Oops. I don't need this one. The comment here. I need it, I think. I don't also need this one. Okay, okay, cleaning a lot of code here. Hopefully it doesn't bite me. This should be okay. I can remove this. So what we did here is we added symbol and S expression as possible lval types. Here we added errors and symbols, which are pointers to a list of characters. So this one is actually causing me. Okay, I need to understand this one better. Okay, I don't think I need this method anymore. Maybe I need. Maybe I do need. Do I? Let me see. Oh, yeah, I do. I do need the print method. But the first one here is the num. Where is the lval num? Where? Here. So let me just. How many? 1, 2, 3. 1, 2, 3, 5, 4, 5, 6. 6. What? 6, delete, delete. And I want to paste it right below the struct. Where are you? Here. Okay, nice. So what's happening here? Okay, what do we have here? I create the new lval that allocates the size. We set its type to lval num. We set stum to x. Okay. Let's also copy the error one. Where is the? It's down there. Here it is. Okay. Okay, okay. Where are you? Where are you? You are here. And I'm pasting you here. Right? Yeah, I can paste you here. Another constructor, it's gonna construct a pointer to a new error lval. Again, allocating the size, setting the type. We do this because of the null terminator, I assume. We copy it to the error object, we return it, same thing with this guy. Okay, let's look for the S expression. Oops. S lval S X, it's here. It's here, it's here, it's here. 1, 2, 3, 4, 5, 6, 7. 7dd. 7dd. Okay. Ah, 7dd. Can I paste it here? Yes. Okay. Okay, let's search for not this one, not this one, not this one, not this one either. No, 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 no. Where's this one defined? Where's this one defined? I need to define it from scratch. What? Okay. There. So this is a void method. It deletes an lval. Okay. So how? How do I do this? I think I have. Do I have here some methods? I don't. Okay. Just a second. Be right back. Okay, I just got some snackies. Case lval s expression. So what will we do in this case? 4. So if it is an S expression for every element that's found inside we count, what will I do? I'm gonna call this method recursively again. Okay. Okay, simple enough. Simple enough. And we also want to free the memory. What will be free? V, right? V cell. What do I need here? I need a break. Not here, but under it. Here, I think. What? Here, yeah. Then we finally free the memory allocated to the struct itself. Okay. Okay, 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 okay. Where are you? Wait, do I have this method already? No. So I need to edit. Oops, no, I don't want a visual, I want insert. Okay, so I want to add, I have an lval of v, I have an lval of x. So where do I want to edit and how do I want to edit? So for people who are joining, I'm following this book. I'm not doing this. You know, I'm not that smart. I'm just a front-end engineer. I'm following this book called Build Your Own Lisp by Daniel Holden. An amazing book. I can't share it because of rules and regulations, but so just so you know, I'm not an expert in this. I'm just learning. Okay. Okay, what this does is adds a new lval to our structure. We increase the memory by this, and then I do this. Okay. Increase this, resize the memory. By how and what? Adjusts. So it will now be able to store recount elements. Recount was increased in the last line, so basically we can store another element. Now this. That's the new element x to the end of the array. Okay. And the turns way. Okay, simple. What else do we have here? The pop method. Do we have the pop? I think we have the pop here somewhere. I think I created it. Where the fuck? Ah, here. Okay. 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 Yank this guy. Let's go above. Let's go above. And below the delete. Paste it here. Okay. I'm just gonna skip a couple of lines so I know where my new code lives. Okay. Okay. lval take. Where are you? Where's the definition here? 5. Delete. Let's go all the way top. Here I can paste it here. Nice. Okay, nice. Do I have this method? New method. No, I don't. Where? I skipped a chapter or a couple of them, but I didn't, right? Maybe I just didn't write it. Because I can find this method too. Yeah. Maybe this is something that has been repackaged as a new method. Let me try to search. Open. No. Interesting. Okay. I could have swear I did this. No. Hmm. I could swear I had this. I had these methods somewhere written. Wow. Interesting. Okay. Okay. Next, we have. We do have this guy. Ah, fuck me. Okay. Where am I? Hmm. Okay. Okay, I need to delete these two entities because I don't think they're I think they are used anywhere. So it's like 229. Okay, no. 229. 269. It's shit. It's 60 DD. Is it 60? 269. 228. 26. It's 40. DD. Okay. I'm just gonna add a comment here. Add the following methods. Lval eval and lval read. lval, but okay. I'm gonna stop here. I'm gonna do a quick break and I'm gonna come back. Thank you.